We're on lesson 2 of chapter 5, which is to solve multiplication and division inequalities. So we're going to do just that in the first part here. We're also going to solve inequalities with negative variables. Then we'll solve a real-world problem. So just like our addition and subtraction inequalities like the last lesson, we treat this just like an equation at the beginning with this inequality sign instead of the equal sign in the middle. So if we're going to solve x divided by 4 is less than 5, we can isolate that x and then solve for x. So we need to multiply both of these times 4. So that would leave us with x is less than 5 times 4, which is 20. If I'm going to plot this out, I'm going to start with 20 in the middle, and we'll say count by 5s, 25, 30, 35, and 40. We'll make this 15 then, and 10, and 5. If I want to say x is less than 20, I want to have an open circle at 20. And then we're going to be heading left with our arrow because it's less than 20. Solve 45 is greater than 5x. So we need to isolate that x by getting rid of that multiplication of 5. So we divide both sides by 5 to get that. So that leaves us with 45 divided by 5, which is 9, being greater than x. So we'll put 9 in the middle here. We'll count by 3's, so 6, 3, and then 0. And we'll make this 12, 15, 18, and 21. I'm also going to go with the open circle here because it's greater than x. And then I see that x is less than 9, so I need to take this arrow to the left again. What happens when you have a negative variable? Well, that changes things. That's what makes it a little different from equations especially. For example, if I go back here, I have 8 is greater than 6, and that's a very true statement. However, if I treat both sides equally by dividing both of them by negative 1, I suddenly have negative 8 is greater than negative 6. That is not a true statement. Negative 8 is not greater than negative 6. So unlike equations where if you treat both sides equally it's going to be just fine, when you're multiplying by negatives or dividing by negatives, you have to flip the inequality. Now that is a true statement. So you got to remember to do this every single time you have a negative variable or you're dividing by a negative number on both sides. You have to remember to flip it. Don't forget that. So let's remember that over here. We have x divided by negative 6 is greater than or equal to 7. So the opposite of dividing by negative 6 is multiplying times negative 6. So we'll multiply times negative 6 there and times negative 6 here. So that would cancel each other out. So now we're left with just x on the left side, and we have 7 times negative 6 on the right side, which is negative 42. But now remember we have to flip this. So instead of greater than or equal to, it's going to be less than or equal to because of that negative flip. So x is less than or equal to negative 42. If we make this negative 42, count by 3's for example, negative 39, negative 36. I can then plot a closed circle at negative 42, and then I would head off this direction because it's less than or equal to it. Same thing right here. I have negative 3x is less than 24. So I would divide both sides by negative 3 to isolate that x. So that leaves me with x on the left side, 24 divided by 3, so negative 8 on the right side. And remember, I have to flip this inequality, so it's now will be x is greater than negative 8. So if we have negative 8 here, count by 2's. Then I would do an open circle this time because it's just greater than at negative 8. And then my arrow is going to be pointing to the right because it is greater than. Let's solve a real-world problem then. A student pilot plans to spend 80 hours of flight training to earn a private license. The student has saved $6,000 for training. What are the possibly hourly rates that the student can afford to pay for training? So the student has $6,000. The student could spend all of that, but it can't spend any more of that. So we know that the spending has to be less than or equal to the total, which would be 6,000. We need to find the hourly rates. That's what we need to find here. So let's make that our variable. Let's do R for rate. So the rate that he pays per hour times the number of hours, which would be 80. So we'll do 80 R, 80 times the hourly rate, needs to be less than or equal to 6,000. So then I would divide both sides by 80. I have R is less than or equal to, I keep it the same this time because it's not a negative number I'm multiplying it by, and then 6,000 divided by 80. That gives me 75. So the rate is less than or equal to 75. And I think that's rate in money, so it would be $75. So this would be the inequality I would write to show how much he could spend per hour. So $50 an hour would be just fine, but anything above 75 would be impossible to get the full 80 hours in.